Okay, so more mature Benabao rules. This is the singleton rule, and what it says is that we always have that this formula is true. The meaning of this sort of turnstile symbol in this context is that it's always true that like if we have, for example, psi turnstile phi, that means that the extension over psi is always contained in the extension over phi. So whereas we'd write this psi dot dot phi to be a sort of proposal that psi implies phi, this says psi always implies phi. And when we have this, we mean that nothing implies this. So this is always true. Okay. So what is it saying? Basically, it's saying that the terminal object just has one thing in it, because exclamation mark is the constant which corresponds to the identity arrow of the terminal object. And we're saying that for all y in the terminal object, y is equal to this exclamation mark. So how can we understand it? Well, we interpret the formula, and the interpretation is for all 1, the transpose of this. So what's the transpose of this? Well, what is this for a start? Well, if we interpret this stuff now with this bound variable 1 dash, it's going to be delta 1 after exclamation mark 1 comma 1. That's this constant here, and then a p2. But exclamation mark 1 comma 1 is just p1. So if you like, this arrow is basically just equivalent to delta 1, because 1 times 1 is equivalent to a terminal object. Now, we have this diagram here representing this sort of exponentiation thing, and the thing is that for all 1 of the transpose of this is going to be true, well, this thing we're calling theta, so if and only if for all 1 of theta bar is true, and since this theta bar is just a point in this power object here, this is the case if and only if the arrow here, which theta bar is the name of, is constantly true. Well, this is an arrow from 1 to omega, so in other words, this happens if and only if this is true. You can see my videos on universal quantification to understand that. Now we're just substituting what we know theta is. We know that theta is delta 1 p1 comma p2 exclamation mark 1 1. So that's true if and only if exclamation mark 1 is identity of 1, and when we know that's always true, because this is just the unique arrow from the terminal object to itself. So okay, that's done. That's the singleton axiom. so-called axiom. It's not really an axiom because we just proved it. But anyway, it's an axiom of local set theory. Here's another one of our sort of foundational results that we want to prove. This is that Q is always equal to Q. This is easy to see. Interpretation of Q equals Q is delta Q of identity comma identity. And that's going to be true if and only if, well, since delta A is the classifying arrow of 1A, 1A, this is true if and only if 1A, 1A is in 1A, 1A, and that's always the case. So yes, equality is always true. This one is called bidirectionality, and it says that this term is true if and only if this term is true. This term on the left is V implies W and W implies V, and that's the case if and only if V is equal to W. So in order to show this, we're going to do the exercise from McClarty's exercise 13.8, which is to show this, that doing the twist on less than or equal to 1 and intersecting it with less than or equal to 1 gives 1 omega comma 1 omega. And we can see this by arguing about elements. So for a general arrow v1 comma v2 from h to omega times omega, we have v1 comma v2 is in this intersection thing. If and only if v2 comma v1 is in less than or equal to, and v1 comma v2 is in less than or equal to, which means that we've got that v1 star is contained in v2 star and v2 star is contained in v1 star, so v1 is equal to v2. Or we could say v1 star is equal to v2 star, but then we get this as a consequence anyway. And that happens if and only if v1 comma v2 is in 1 omega comma 1 omega. So these have the same elements, same generalized elements, so they're the same subobject. Okay, now let's use that. So we want to do, so we'll go back to thinking about this. We'll do the extension over this and compare it with the extension over this using that previous result. So extension over this left part, it's a subobject classified by the interpretation of V implies W and W implies V over V's and W's. Interpretation of that is and implies P1 comma P2 implies P2 comma P1. This P1 comma P2 is just the identity, and this arrow, this implies, is chi of less than or equal to. So this is equal to and of chi is less than or equal to, comma chi is less than or equal to P2 comma P1. This is the twist arrow, okay? So R is equal to A intersection B, where A is the arrow classified by this. A is the arrow classified by this, and B is the arrow classified by this. And I claim that B is equal to P2 comma P1 less than or equal to. I claim that's the arrow classified by chi less than or equal to 1, P2 comma P1. Well, let's prove that. So chi less than or equal to 1 of P2 comma P1 operating on x and y, we'll just consider some generalized elements of x and y, x comma y, that's going to be true if and only if chi less than or equal to 1 of y comma x is true, if and only if y comma x is in less than or equal to 1, if and only if there exists a k such that y comma x is less than or equal to 1 after k, if and only if there exists a k such that P2 comma P1 after y comma x equals P2 comma P1 after less than or equal to k. We can do that because this P2 P1 thing's just an isomorphism. And then we have that this is true if and only if y comma x is in P2 comma P1 less than or equal to. So we've shown that x comma y is in this. Sorry, we've shown that x comma y is in this if and only if doing this on x comma y gives true. So this must be the subobject classified by this, which is what I claimed. Okay, so we can write R is equal to A intersection B, where A is less than or equal to 1 and B is P2 comma P1 after less than or equal to. So if that means R is equal to, drum roll, this thing we've already considered and shown to be equal to 1 omega comma 1 omega, which is equal to the extension of V equals W over V and W. So we've shown these objects are equal, and therefore we've proved that in general this term, this formula implies this formula and vice versa. And we normally write V left arrow right arrow W instead of V equals W when we're talking about formula.